All right, so again, we're writing the final answer as an ordered pair, so that would be -1 for x, comma, -3 for y. And then if we graphed both of those lines, we would find that's the point where they cross. You guys good with that one? All right, so I mean, all the rest of them are the same, so let's go to number 2. And kind of read those steps, okay? I'll kind of remind you what the steps were. So step 1. Step 1 says solve one of the equations for one of the variables. Do we have that already? On number 2? We do? What do we got? So on number 2, do we have one of the equations solved for one of the variables?
No.
Do we have x or y by itself on one side of the equal sign in either equation? Come on, 2 days ago I couldn't get you guys to stop talking. Now today you won't talk at all. You can give me the phone too. Is either equation solved for x or y?
Yeah, the top one.
The top one is solved for what?
Y.
Good.
Yeah.
Yes, the top one is solved for y. So that means the top equation says y is equal to x plus 1, or y is the same thing as x plus 1. So I can take that x plus 1, and I've got to plug it into the other equation. All right? That was step 2. So step 1 was to solve one equation for one of the variables. That was already done for you. Step 2 is to substitute the x plus 1 in for y in the second equation. And then that make the second equation look like this then. The second equation would now be 4x plus x plus 1 equals 6. Now, I put those parentheses in there just so that you can see what I plugged in for y or what I substituted for y. You don't really need those parentheses, okay? If that's a 1 right there and that's a 1 right there, you can drop the parentheses. The only time you need parentheses is if there was if there was a number in front of that quantity in the parentheses like that. Then you would need them because you'd need to distribute. Same thing if that quantity had a power on it, like that, then you would need the parentheses still, all right, because there's a power other than 1. So since this one has a 1 in front of it and a 1 for a power, then you don't really need those. I was just trying to show you what you were substituting. Okay, so on the left-hand side now, how many x's do I got? Well, I got 2 x terms, but how many do I got all together?
5.
Yes, I have 5. If you put those together right there, that's 4x plus 1x. So that would be 5x. Plus 1 equals 6. So right now we're working on step 3 of the process. We're solving for the variable. We're solving for x. Then we would subtract 1 on both sides, and we get 5x equals 5. And then divide both sides by 5. These cancel out, and I get x equals 1. All right, so that was step 3. Step 4 says take that solution and plug it into one of the original equations in order to solve for y. So I've got x equals 1. I guess I can circle that. And I'm going to take that. That's half of our solution. I'm going to take x equals 1, and I'm going to put it in right there. I'm going to put it in for that x. So then that top equation would become y equals 1 plus 1. And again, I don't really need to put those parentheses around that 1. I was just trying to show you what I was substituting in. So I could take those parentheses out of there. So 1 plus 1 is 2. So I get y equals 2. And again, for me, that's good enough. You got your x is 1, that's circled. You got y equals 2, that's circled. But again, in the book, they want you to write it as an ordered pair. So the x goes first, and then comma, the y goes second. So again, if we graph those two lines and we look for the point of intersection, it would be at the point 1, comma 2. Well, let's keep going. I'm just going to go, I'll go straight down here. We'll go out of order. Let's do number 4. So number 4, first step, solve one of the equations for one of the variables. Do we have that? Yeah, which equation? The top one. And the top one is solve for what? Yes, it is solve for x. The x is all by itself. So that means x is the same thing as 2y minus 4. So we can take that and plug that in for x into the other equation. Right there. So that second equation is going to become 2y minus 4 plus 8y equals 16. But again, I just put those parentheses there so that you can see what the substitution was. So we don't need those. So let's take those back out. All right, now how many y's do I got on the left-hand side? In other words, I can combine that and that together. Those are already on the same side of the equal sign. They're on the left-hand side. So how many y's do I have altogether?
10.
Yep, I got 2y terms, but I got, they add up to 10, right? I got 2y plus 8y, that's 10y. And then bring down the minus 4. And then that's equal to 16. And then add 4 on both sides. Those cancel out, I get 10y equals 20. Divide both sides by the number out in front of the variable. Those cancel out, and I get y equals 2. All right? So then I got y equals 2. And then I could plug that y equals 2. I could plug it in for this y right here in the bottom equation. Or I could put it in for that y there in the top equation. I think it'd be easier to plug it in the top one because we're trying to find x, and that one is already solved for x. So I would take the y equals 2 here. I would take that, and I would plug that in right there. So then that top equation would become x equals 2 times y minus 4. So we got 2 times 2 minus 4. What's that? What's that?
0.
Yeah, good. Good, Damien. Yeah, that's 0. So there's the other half of my solution. So now I have my x coordinate and my y coordinate. So my solution is at the point x is 0, y is 2. All right, let's keep going. So let's go to number 3. Now, is either equation solved for either variable? No. Now, what would be easiest to solve for? We got to solve either the top equation for x or y, or we got to solve the bottom equation for x or y. The bottom one? What would you want to solve for? X or y? Good, Ethan, that's good. Yeah, you don't want to solve for y in the top equation because it has a 2 in front of it. So that means at some point here, you'd have to divide both sides by 2, right? That would make it more complicated. Same thing on this bottom equation right here. You have a negative 1 in front of that y right there. So at some point, if you want to solve the bottom equation for y, you'd have to divide both sides by negative 1, which you really don't want to do. So the best choice probably would be to, well, really you could solve the top equation for x because it has a 1 in front of it, or you could solve the bottom equation for x because that also has a 1 in front of it. So I'm going to go with what Ethan said. He said solve the bottom one for x. So all I got to do to solve the bottom one for x is just add y on both sides. So that bottom equation becomes x equals, these cancel out, so I just get 5 plus y. All right, so that was step 1. Step 2 is substitute that resulting expression into the other equation. So we're going to take that 5 plus y and we are going to substitute that in for x in the other equation. So x is the same thing as 5 plus y. So we're going to put that in right there. So that means that top equation is going to become 5 plus y plus 2y equals negative 1. And again, I don't need those parentheses. So let's take those out of there. And then, how many y's do I got on the left-hand side? I have 2y terms right here. So 1y plus 2y? Pardon me? Yeah, it's 3y, good. So that's a positive 3y. I got to bring down that 5 in front, and then that's equal to negative 1. Then we're going to subtract 5 on both sides. Those are going to cancel out. On the left, I got 3y, and on the right, I've got negative 1. Take away 5 more. That's negative 6. Then I'm going to divide both sides by 3. Those cancel out, and I get y equals negative 6 divided by 3 is negative 2. So there's half of my solution. Now I could go, I could plug that y equals negative 2. I could plug that in for y in the top equation right here. Or I could plug it in the bottom equation for y right here. But I think the easiest place to put it would be to take that y equals negative 2. I think it'd be easiest to take it and put it in right there. Because that equation right there is already solved for x, right? So then if I just plug in my y, I'll have my x. So that bottom, or this one right here, this one, if I plug in y equals negative 2, that's going to become x equals 5 plus negative 2. Well, what's 5 plus negative 2? That's 3. Same thing as 5 minus 2. So x is equal to 3. So my solution to the system is x equals 3, y equals negative 2. And again, in the book, I think they say to write it as an ordered pair. So remember, the x comes first. That would be 3. Then the y would be negative 2. That would become second. All right. So there's the third one, or number 3. Let's look at number 5. So on number 5, step 1 is either equation solve for x or y. And number 5 right now, is there an x or a y all by itself on one side of the equal sign? None? No. Which one would be the easiest one to solve for? X or y in the top or x or y in the bottom? Ethan said x on the bottom. If I chose to solve for x on the bottom equation, at some point I would have to divide by this 3, which could give me some fractions in there, which I really don't want. So which would be the easiest one to solve for? X or y on the top or x or y on the bottom?
Y on the top.
Yeah, y on the top would be the easiest one because that has a 1 in front of the y, right? So that would definitely be the easiest variable to solve for. So all we'd have to do to solve for y on the top then is we would just subtract 6x on both sides. Those would cancel out on the left-hand side. So then that top equation would just become y equals 11 minus 6x. So that was the first step. That's step one, solve one of the equations for one of the variables. The second step is you substitute that result into the other equation. So don't put it back in the same equation, all right? You got to put it in the other one. So you're going to substitute this, 11 minus 6x. That's the same thing as y, right? So you're going to substitute that in for y in the second equation. So now that second equation would become 3x plus 2 times y, where y is 11 minus 6x, and then that would equal negative 5. Now, do you see on this case, I need the parentheses there? I substituted in 11 minus 6x for the y in the second equation. I have to have the parentheses there because I have to do what? What's that?
Distribute?
Yeah, good. Good, Damien. Yeah, I got to distribute. So that's a positive 2. I mean, if it was a negative 2 there, I'd have to distribute a negative 2. You know what I mean? Like if that was a minus right there, if that happened to be a minus, I'd have to distribute a negative 2. But it's a plus. So I'm going to distribute this positive 2. So I got to do the positive 2 times the 11, and then I got to do the positive 2 times the negative 6x. So then this equation would become 3x plus, well, positive 2 times positive 11. That's a positive 22. And then what's a positive 2 times a negative 6x? Neve, what's that? Negative 12x, yeah. And so since it's a negative 12x, I'm going to write minus 12x. And then that equals negative 5. And then I can combine this right here. I got 3x take away 12x. So if I got 3x's take away 12x's, how many x's do I got?
9?
How many?
Negative 9?
Yeah, negative 9. Good. So negative 9x's plus, bring down the positive 22 there, so plus 22 equals negative 5. Now we got a two-step equation, so we're going to subtract 22 on both sides. Those are going to cancel out on the left-hand side, so I got negative 9x is equal to negative 5, take away 22 more is negative 27. Then I'm going to divide both sides by whatever number's in front of that variable. Those cancel out on the left-hand side, and I get x equals negative 27 divided by negative 9. What's that? Yep, a negative divided by a negative is a positive, so that's a positive 3. All right, so that was all right there. That was all step 3 in your directions. That was solving for the variable. Then step 4 says plug that solution into one of the original equations. So I could take that x equals 3, and I could put it in right here in the top equation. Or I could put it in next to the, like 3 times 3 right here. I could put it in the bottom equation. But I think the best one to put it in would be this one over here that's already solved for y. Because I'm trying to solve for y. So I would actually think the easiest thing to do would be to take that x equals 3 and put it in right there. Because then that equation will just become y equals 11 minus 6 times 3. All right, and so then that gives you y equals 11 minus 18, which gives you y equals negative 7. So then your solution would be the ordered pair x equals 3, comma, y equals negative 7. Now, I haven't done it, but make sure that you could check your answers, right? All you'd have to do is you go back to the original 2 equations, And you would have to plug in 3 for the x and negative 7 for the y, and make sure that this makes a true statement. And then in the bottom equation, same thing. You'd have to do 3 times the x plus, so that would be 3 times 3, plus 2 times the y, plug in the y right there, that'd be negative 7. And then make sure that that comes out to equal negative 5. Because remember, your solution here, the ordered pair, that has to make both of the original equations true at the same time. All right, so what do we got left? Just one? Last one? And this pretty much looks exactly like the story problems yesterday. All right, so this one, there's 2 cell phone plans. The first plan is $50 to sign up and then $20 per month. So what's the slope, the 20 or the 50? It says you pay $50 to sign up and then $20 per month. Rachel? Which one's the slope, the 20 or the 50?
Oh,
The 20. So the 20 is the slope. So the 20 right here, that is the slope. That means the 50 right here, that is the b or the y-intercept. Well, that means that that equation is going to look like y equals 20x plus 50. And then the other equation, what do we got? It says the second plan, it's $30 to sign up and $25 per month. So what's the slope, the 30 or the 25? The 25, good. So the 25 here, that is the slope. That's M. And the $30 to sign up, that's what you pay up front. That would be your B or your y-intercept. So that second equation would be y equals 25x plus 30. All right, again, where in this case, x is going to represent, well, it's $25 per month, right? So x is going to represent the number of months. And then y is going to represent the cost or the total cost. All right, well, then you got to solve this system. So this is your system of equations right here. Let me try that again. So that's your system. Well then, y is equal to 20x plus 50, right? So if y is the same thing as 20x plus 50, all you got to do is take that and substitute it into the first equation, or sorry, the second equation for y. Which is exactly what I did on that last example yesterday. I just didn't tell you that. So then that'll give us an equation that looks like 20x plus 50 equals 25x plus 30. Then we're going to solve for x, so we're going to subtract 20x on both sides. These cancel out on the left-hand side, so now you got 50 equals 25x minus 20x is 5x plus 30. Then subtract 30 on both sides. I'm running out of room. So then I'm going to get, come up here. I'm going to get 30, or 50 minus 30 is 20. So I get 20 equals 30 minus 30, that cancels out. So all I have on the right-hand side is 5x. Then I divide both sides by 5. Those cancel out, and I get x equals 4. Now, what did x stand for again?
the months.
Yeah, the number of months. So x equals 4 months. So that's the first part of your solution. Now let's take a look at what all these questions are here. So let me erase this stuff. All right, so So what do we got? So the first question is, after how many months will the total cost be the same? Well, I set the two equations equal to each other right here, right? And we solve for x, so we know now that after 4 months, the cost will be the same. So we answered the first question. So then the second question says, oh, where is it here? It says, what will that cost be? So what do? I know the cost will be the same after 4 months. Well, how much would that be then? What do I have to do, guys?
Put the 4 into the 20th.
Yeah, plug the 4 in, right? And it doesn't really matter which one I plug it into. I can take the 4 and I can take the x equals 4 and I can plug it in right there for that x. Or I could take the x equals 4 and I could plug it in for that x. It doesn't matter because at that point, the costs are going to be the same, right? After 4 months. So I'll just plug it in the top one. So let me get a little more room here if I can. So I'm going to do y is equal to 20 times 4 plus 50. So 20 times 4, that's 80. 80 plus 50 is 130. So I get y equals 130. That's the total cost. So that would be in dollars. I'll put a dollar sign there. So that was the second question. But then on this one, there's actually a third question. The third question is, which plan is cheaper after 1 year? Well, 1 year is how many months?
12.
Yeah. So what do I got to do here then is I've got to, 1 year is, that's 12 months. So I got to see which plan is cheaper. So I'm going to take the 12 and I'm going to put it in right here in the top equation. I'm also going to put the 12 into the bottom equation and then find out which one would be cheaper after a year. So let's do that. So that would look like y equals, I can't remember what the equations were, 20 times 12 plus 50. The other one would be y equals 25 times 12 plus, what was it? What was the other b? 30? Okay, so then the top one, that's 20 times 12, that's 240 plus 50, that's what, 290? So that would be $290. The bottom one, you got 25 times 12, that's 300 plus 30, that's $330. Which one's cheaper?